Hi everyone. I'm here to present AudioworX. My name is Ravish. I work as a distinguished engineer / director for AudioworX. Briefly, I will touch upon HARMAN as a company, what we do, and some of the brands we are associated with. And then I'll walk you through how we accelerate audio development using AudioworX. We'll end the session with a small demo by my colleague. So who we are? HARMAN as a team, we are 30,000 professionals worldwide. We have 15,000 engineers and 80% of them belong to software. We are across 30 different countries across the globe and 16 legendary brands. We have many patents on our name, many awards, and 3 Grammy awards as well on our list. So as a HARMAN, as a company, have made 4 different divisions out of it. Of course, it's not the reality. You have many divisions in it. For the talk specific, I've made 4 different. We have connected car, lifestyle, professional, and connected services. Connected car deals with any of the connectivity side of it, where you have a BT5, Bluetooth connectivity, display, safety, security solutions. And in terms of lifestyle, we work with branded audio products and the sound management side of it. We do a car audio, home entertainment, all of this comes under lifestyle division. And then we have professional solutions where we do audio, lighting, and video solutions for concert halls or theaters or any of the bigger events. And then we have a connected services who works on a cloud and mobility as a service division of HARMAN. So we are house of brands. We have many brands under lifestyle. You might have heard JBL, Infinity, Revel, HARMAN Kardon. These are the lifestyle brands. And then you have a professional as well as a JBL branded in India, AKG, Lexicon, DBX, and also there is something called Martin Lighting, which provides a lighting solution with audio as part of it as well. So I'll start with a small video and on what HARMAN is and what it takes to build a car of a complex audio system, and how we manufacture this, how we wire that, how we rip off the car to give us the best audio system. The video shows audio processing system, which is having 32 speakers in it. It has 14 high-end speakers, I think 8 mid-range speakers, and 4 subwoofers. And all in all, to power all of this, it uses 5 JBL amplifiers in this car. Let's see the video. As you see, there's a huge amount of audio processing being done. As a company, as HARMAN, right, we have professional solutions and car audio, home entertainment, consumer speakers, headphones. Everywhere you need audio processing. And we need to develop this fast, and we need to make quality product. We need to make sure we get it to the market faster. So that is where our product comes, AudioworX. And let me start with some of the challenges what we have, right? So you see there are 3 different cars in a venue. Left side car is a pretty high-end car, which is might be having 16 different speakers in it, and the right one is a basic mid-range car, and the leftmost is the low-end car. And then you have a concert hall, which might be having 40 different speakers. So you see here, we need to build our audio system quickly to adapt to all different conditions. And you should be tuning it according to the acoustics of the car. For example, you have a high-end car which has a leather seating or a cloth-based seating. You have a different sound absorption there. There is a different acoustic conditions, the wood there, and it is entirely different conditions. And then you have width of the car, the distance between the two speakers also is different. And you need to, if you want to give a good sweet spot for a driver side, you need to make sure you adjust your delay, gain, and of the speakers to give you a sweet spot for the driver. And that's our tuning. So you need to, and also the first car, maybe it's a pretty high-end car which has a huge amount of processing. It will have very high-end audio processing requirement as well. And whereas the mid-range or the low-end ones will be a basic cars. When you come to the concert halls, you have 40 different speakers. You have a completely different acoustic conditions. The amount of processing requirement is also huge. And we should have a framework, or we should have a product which is scalable. So we should be able to scale in terms of number of speakers, number of processing. We should be quick in the market, and we should have a output, a quality product out of it. So our solution is basically AudioworX. And as just describing the process with AudioworX with some Lego blocks. So your vision is to have build a house, right? And how we do with AudioworX is like you will have smaller components in it. So you have step one, you have 10 components. Using that, you build one smaller box, and you can make this box also as a component so that that can be replicated in multiple places to build your house. For example, if you're doing a window, it is made up of multiple steel rods. Each steel rod is a component. You make a window and then keep that as part of your setup. Now you can instantiate it multiple times to bring your house. Plus, you might have customer-centric algorithms which you need to integrate and make the customer proprietary algorithm also part of your car. And that, with the addition, you will end up with a pretty good house, which is better than what you visioned. The reason for that would be you have already tested algorithms, you have already acoustically proven performance of those algorithms, and that's been grouped together to give you a better performance compared to what you had visioned as well. So our solution basically is AudioworX. AudioworX has, how we do that is we have a DSP library. You load that into a UI component, and in the UI component, it will let you design your audio post-processing pipeline. And you design this pipeline, click of a button, you can realize that onto your simulator or onto the target. And on this simulator and the target, we are running our framework, which will be understanding what UI is popping it out, and it will be able to reconstruct your entire audio pipeline on your target or the simulator. You perform the tuning, you might do a virtual tuning on your simulator, or you go to the target, do the tuning, and then you can bring back all of these outputs together back to your PC and compare whether the simulated output and the implemented target output works same or not. And what do we have? In AudioworX, we have 3 different layers. We have XAF, AAT. XAF is Extendable Audio Framework. AAT is Audio Algorithm Toolbox, and GDT is Global Tuning Tool. So XAF is a DSP framework, and what it does is it defines standard APIs for your audio algorithms to be implemented, and it also takes care of memory management, interface to the hardware, interface to the external world in terms of tuning to the global tuning tool which we have, and also to the any of the RPM data or any of the control data which is coming in as well. And then we have AAT, Audio Algorithm Toolbox. This is a house of different algorithms across HARMAN being put into this. You would be able to use this in your UI to drag and drop and make your pipeline and build your audio system. The Global Tuning Tool is a UI basically, and this lets you drag and drop all of your algorithms, make a pipeline, then perform tuning, acoustic tuning with it, and then also you could do measurement. So you can run the measurement module there, run the measurement on your car, get your measurement, analyze that, tune that system to get the best results out of it. All of these layers are connected through a protocol called XTP, Extendable Tuning Protocol. Continuing with same architecture, this is, I've given an example how it looks like. You have a PC where you have a global tuning tool running there. You drag and drop all your algorithms in it, make a pipeline which you want to realize onto different units. So in this example, I have connected the PC to a head unit and an amplifier. And head unit has capability to run 3 different audio processing elements in it. Amplifier, which is having around 4 audio processing units running there. All of these things can be tuned together with the global tuning tool, and all of these pipelines can be flashed together with the interface connected to the head unit or the amplifier. All these units runs XAF framework in it, and that's why whatever the tuning tool which is popping out, this is able to realize and run that. So you have, first you have the pipeline ready, which is run on the head unit and DSPs you have here. And then you make an additional tuning to it or additional algorithms you would add, enhance. You don't need to go and change the code again. You don't need to recompile the entire code, burn that. You don't need to do anything of that sort. You just click a button on the global tuning tool, you have the whole thing realized onto your head unit and amplifier. It also has capability to get maps and memory. It tells you when it is out of memory. You can place your memory the way the region you want to do in DSPs, as you have multiple L1, L2s. You can configure any of them. So I'll briefly touch upon the features of our tool, as in some screenshots, and then my colleague Harish will take you through a small demo on this. So as I mentioned, this is a basic car, the audio processing which I have put in here. Each of these modules are basically your audio processing modules. And you can see that you can do a metering, get an RMS value of every output of the audio object. We call that as audio object, which is nothing but audio algorithm actually. So all of these pipelines can be realized. You have panels for tuning them. So left side one is an IAR panel. So you can graphically go and configure your cutoff frequency or quality factors in this IAR graph, and which will translate into coefficients onto your embedded device. And the same way, the right side one is a example of a tone control, which is realized as an loudness module here. User can define their own panels as well. You don't want to expose all the parameters to the end user. You have a big pipeline put up, and you don't want to go and expose everything into end user. So you can develop your own panels using the internally panels created using our tool. Here you can embed your own image onto it. The left one has an HARMAN Automotive AudioworX logo in it, and you can expose only the basic, like increase of volume, mute of the master mute for the entire car, and bass and treble maybe. All of this can be done over here. And then you have the right side where you can embose your own car video, image, and then go each and every seat, passenger seat, mute, unmute, take the polarity change, everything you can position and give as well. Then we have something called measurement module. This measurement module, basically you can measure your car. So how we do it is we probably use 6 mic array inside your car. You place this microphone array physically in the car, and you can configure the measurement module to depict the car, which probably has, in this case, it is 9 speaker system. 9 speaker system is configured in this example, and you have placed 1 mic array in the driver's seat. So you can configure this measurement module in such a way that do a 1 microphone measurement, or do multi-speaker measurement, or do a measurement of individual speakers with all 6 mic arrays. You can configure all of that, press start. It will go do the measurement of the car, multiple sessions, wherein first time the speaker 1 is turned on, speaker 2 is turned on, speaker 3 is turned on, and all the speakers turned on with 6 mic arrays. All of this can be configured, do a start, and it's only possible because all of this is integrated into one tool. The global tuning tool knows what is audio processing which is running on your target. It can reduce the gain, mute a channel, unmute it, and do the measurement as well. What I've shown is an example of the resultant measurement, what we have here. And if you want to do more analysis on the measurement which you have performed, we have something called central viewer, and wherein you can get the individual measurements displayed. You can do some banding, you can do some smoothing. All of these operations are supported on this. So next comes the, I talked about how we build a pipeline, how you can tune it. We have panels, we have measurement module which can do measurement of your car, and then comes the technologies which are part of AudioworX, right? So I've classified broadly around 3 categories: sound, performance, acoustic, and passenger convenience. So in terms of sound performance, I'll pick one example here and walk through a bit. Clarify. So it is basically an algorithm which tries to reconstruct the lost bits due to the compression. And that's one of the modules we have. We have quantum logic, which does the upmixing. In the same way, in acoustic environment, we have something called virtual venues. Basically, what it means is it tries to mimic the venue in your car. So we go to the particular venues, concert halls maybe. We get the measurement from the row number 1, mid rows, and the last rows, and bring that environment back to your car. So you choose a venue 1, it sounds like a particular concert hall. And that's virtual venues. And then we have some of the halosonic algorithms, which is basically sound synthesis, cancellation, road noise cancellation. All of this comes as part of the halosonic area. And then we have passenger convenience, for example, ISZ, which is actually individual sound zone. So what it tries to do is, let's say you have a navigation prompt which is coming in. So the navigation prompt need not be heard by all the passengers in your car. So what it does is it pops out the navigation prompt only to the driver's side, and it cancels out that prompt onto the other speakers. So the passengers are not being disturbed at all from the music which is being played. So the same way it is applicable for some phone calls as well. It does tries to build an individual sound zone so that the 2 phone calls which are happening in parallel is not getting disturbed. Yeah, so we have around 100 plus audio algorithms which can be used to realize your pipeline. And yeah, next Harish will show a small demo on how we can do it using a synthesis.
Right, so hi, I'm Harish. I work as a senior software engineer. 1 minute to go. 1 minute left. Okay, I'll just keep this quick. Might go over 1 minute. But yeah, what you're seeing here is the one tool that a DSP engineer and an acoustic engineer would need, right? DSP engineer to basically rig up a signal chain graphically, much like how you've seen over other presentations. And an acoustic engineer would go measure in a car, with the car, and also tune the experience within a car. So what you're seeing here is an abstraction of what your audio system has. Audio system might have multiple devices, like he said, multiple cores. So what you see here are only the cores that are capable of doing audio processing, right? Let me go into one of these modules which does the signal processing, and you have all of these audio objects in the toolbox on the left, which you can basically drag and drop. Ravish has gone over multiple. There are also you can also make abstractions within your SFD or the signal flow design with basic objects, right? And we call them compound audio objects. You can also create panels for controlling the entire SFD with drag and drop methodology. You can put buttons, faders, knobs, whatever you want. And then finally, we have IVP and RTA, which is basically for simulation of your SFD, right? And you can also visualize the signals coming through the simulator, as well as from your sound card, which would generally contain sounds from your target device, right? So what you see here is basically the microphone input, which is shown as a spectrum, right? There's a spectrum analyzer, and we're going to go over a simple example of car sound synthesis. Aaron did a very good job at explaining what are the challenges in designing sounds for a car. He also went over things like AVAS, which is acoustic vehicle alert system, and also the engine sound enhancement, right? You want to be able to play engine sounds within your car. So, you hear that? This is basically an example showing what an engine would really sound like by modeling the vibration orders of the engine. So car manufacturers would basically tune their engines to sound a certain way. He mentioned V4, V6, V8, V12. Each car has its own sound, right? So a car manufacturer would give us the analysis of what are the orders, how are the orders placed, how do they sound, how do they interact, all of that, and then we basically put everything together, map them to control parameters like RPM and torque that actually come through the CAN bus. And we can form any complex mapping between the control parameters. For example, I'm showing you RPM versus gain of each of these orders of vibration, right? You can have something like this. And finally, here what we have is a fader representing what the engine RPM is. Well, we have so much capability, why just limit ourselves to just mimicking an engine sound? You can even add other forms of synthesis to get more complex sounds and basically play around to achieve any given sound and map them to different parameters within the car. I'm sure this is very rudimentary. If Aaron had, I don't know, had access to this, he'd come up with a killer sound, but this is what I could. Yes. Here the speed is also mapped to road noise and wind noise, right? Which is simulated through stochastic noise being filtered by two-pole bicode, right? And then pedal sound, pedal can be mapped to something like volume of certain oscillators to let the driver know how much he is depressing the pedal. So we can generate a variety of sounds all within GTT through these drag and drop tools, synthesizers, and basically tweak them on the fly. And that brings us to the end of our demonstration and our presentation, and we can open the floor for any questions.
Is this only available for in enterprise solutions, or can like someone who wants to get into this field, who's like a technical sound designer, but wants the background, so that if there's someone who in the future, like if a company in the future is gonna use it, can we like get access to this, or do you have to be an enterprise to only get it?
We will soon open up into the public, but currently it is not. So we have few of our customers using this for sound design. We make the primary model and give it to them, and maybe customer will add their own algorithm on top of it. Then probably you need to do a retest in terms of tuning. That's how it has been shipped to our customers as well. So we will soon go to public. Yeah.